Hello everyone. So let us solve the problems on water requirement of crops. Okay. So an irrigation canal has a gross command area of 80,000 hectares, out of which 85% is culturable irrigable. The intensity of irrigation for Kharif season is 30% and for Rabi season is 60%. Find the discharge required at the head of the canal if the duty at its head is 800 hectares per cumex for Kharif season and 1700 hectare per cumex for Rabi season. Okay, so first thing is the gross culturable area. So first see what is the gross culturable area. So total 80,000 hectares. Okay, it's given. Then out of which only 85% is culturable. So culturable command area is CCA, which is 85%. So it is 0.85 into 80,000 hectares. So it is 68,000 hectares. And then okay, so we have two seasons here. One is the Kharif season and another is the Rabi season. So area under the Kharif season is 30%. So it is 68,000. So which is culturable command area. So 68,000 into zero point 0.3. So it is 30% means zero point 0.3. Okay, so it is 20,400 hectares. And area under the Rabi season is 60%. So it is 68,000 into zero point 0.6, which is 40,800 hectares. So ultimately, we have to calculate the water required at the head of the canal for both the season. So water required for the head of the canal for Kharif crop is equal to area divided by duty. So total area under Kharif season is 20,400 divided by duty. So duty of this is given here 800 hectare per cubic. So it is 20,400 divided by 800, which is 25.5 cumex. Similarly, you have to calculate the water required at the head of the canal for Rabi crops. So for Rabi crops, it is again area divided by duty. So area is 40,800 divided by duty, which is 1,700 hectare per cubic. So it is 24 cumex. So since the water requirement in Kharif is more, so the canal may be designed for a discharge of 25.5 cumex. So out of which you have to Kharif crop requires more water head, so it should be designed for 25.5 cumex. Okay. So the next problem is water. The watercourse has a culturable command area of 2,600 hectares, out of which the intensities of irrigation for perennial sugarcane and rice crops are 20% and 40% respectively. The duty of these crops at the head of the watercourse are 750 hectare per cubic and 1800 hectare per cubic respectively. Okay, so 750 is for sugarcane and 1800 is for rice crops. Find the discharge required at the head of the watercourse if the peak demand is 20% of the average requirement. Okay, so first let us check out what is given. So it is a culturable command area. So it is CCA, culturable command area, which is 2,600 hectares. And out of which 20, okay, the 20% is for sugarcane. So area under sugarcane is 2,600 into 20%. So it is zero point 0.2. So it is 520 hectares. And area under the rice. So it is 2,600 into, so it is 40% for rice. So it is zero point 0.4. So it is 1,040 hectares. Okay. Now we have to calculate the water required. So water required for sugarcane is area divided by duty. So area is given, that is 520. Duty for sugarcane is 750. So divided by 750. So that would be 0.694 cumex. Cumex is nothing but cubic meter per second. And water required for rice is again area divided by duty, which is 1,040 into 1,040 divided by duty. So duty for rice crop is 1,800. So 1,040 divided by 18 is 0.5 cubics. So, since sugarcane and rice are perennial crops, that means they require water throughout the year. So, you have to calculate the discharge for both. So, it is 0.694 cubics plus 0.577 cubics. So, add both of them. So, a water course must carry a total discharge of 0.694 plus 0.577. So it is 1.271 cubics. You have to add both because they are perennial crops. So you need to add them both because they require water throughout the year. Okay, these problems will be asked for 6 to 8 marks. So it is simple. You have to first calculate the culturable command area, then area and area of the given crops, followed by the water requirement. Okay, next. The left branch canal, carrying a discharge of 20 cubics, has a culturable command area of 20,000 hectares. The intensity of the rabi crop is 80% and the base period is 120 days. The right branch canal, carrying a discharge of 8 cubic, has a culturable command area of 12,000 hectares. Intensity of irrigation of rabi crop is 50% and base period is 120 days. Compare the efficiencies of the two canal systems. Okay, so again in the given problem, so first split this into two, that is for left branch canal and right branch canal. Okay, so write the data for the left branch canal first, that is carrying a discharge. So discharge of left branch canal is 20 cubics and culturable command area is 20,000. Okay, culturable command area. The intensity of the uh, rabi crop is 80% and the base period is 120 days. Okay, so area under the rabi crop is 20,000, but the intensity of that crop is 80%. So you have to take 20,000 into zero point 0.8. So it is 16,000 hectares and discharge is 20 cubics. So duty is nothing but area divided by discharge. So area is 16,000 divided by discharge is 20. So it is 800 hectare per cubic. Similarly, calculate the same thing for right branch canal. So right branch canal, it is 12,000 hectares. 12,000 hectares and the intensity of irrigation is 50%, and the base period is same again, that is 120 days. Okay, so now you have to compare the efficiency. So here for the right branch canal it is lesser, the area is lesser here and discharge is also lesser. So area is 12,000 and total irrigation area is still 50%. So it is 12,000 into 0.5 and discharge is 8 cubic. And so duty is equal to area divided by discharge. So area is 6,000 divided by discharge is 8 and it is 750 hectare per cubic. So now we can just check out, we have to compare both, that is right branch canal and left branch canal. So since left branch canal system has higher duty, it is more efficient. Okay, you can see here left branch canal has higher duty, that is 800 hectare per cubic and this is 750 hectare per cubic. So left branch canal is more efficient. Okay, so the next problem is a watercourse has a culturable command area of 1200 hectares. The intensity of irrigation of a crop A is 40% and B is 35%. Both the crops being rabi crops, crop A has a core period of 20 days and crop B has a core period of 15 days. Calculate the discharge of the watercourse if the core depth for crop A is 10 centimeter and for crop B it is 16 centimeter. Okay, so the first again split that into two categories. For crop A, calculate first, write all the data given. There is area under irrigation. So for crop A, the area under irrigation is 40%. Okay, so it is 1200 into 40%, so 1200 into zero point 0.4, it is 480 hectares. Then core period for crop A is 20 days, and core depth is core depth for crop A is 10 centimeters. So 10 centimeters is nothing but 0.1 meter. So now duty is given by the formula. When you we have a formula for calculation of duty, delta and base period. So that is duty, delta and base period, that is 8.64 into B divided by D. So B indicates, small b indicates the core period, and this delta indicates core depth. So duty is given by 8.64, B divided by D. 8.64 into B is 20 divided by depth D is 0.1. So duty is given by 8.64 into B divided by delta. So it is 1728 hectare per cubic. So now the discharge required is area divided by duty. So which is nothing but area is 480 divided by duty 728. So it is 0.278 cubics. Similarly, calculate the same for crop B. Again, area under integration irrigation for crop B is 1200 into 35%. So it is 420 hectares, and core period is 15 days. Core depth is 16 centimeter. So it is 0.16 meter. So duty is equal to 8.64 B divided by delta. So 8.64 B divided by delta. So B is 15 days, delta is 0.16. So it is 810 hectare per cubic. So now the discharge required is area divided by duty. So it is 0.518. So thus the discharge of the water course should be designed for both the crops, that is mm, crop A and crop B. So for crop A it is 0.278, and for crop B it is 0.518. So when you add this, it is 0.78. So we have to round off the value. So it would be 0.8 cubics. Okay. Next, the factors affecting duty are the duty of the water of a canal system depends mainly on the factors that are the methods and systems of irrigation, mode of application of water to the crops, then method of cultivation, and time and frequency of tilling. So tilling is nothing but it is leveling and plowing the land, and types of crop, base period, climatic condition, quality of water, method of assessment, canal conditions, character of soil and subsoil of canal, as well as irrigation fields. Now, the factors um, affect the duty should be improved. So, improving the duty are, so suitable method of applying water should be used, and the land should be properly ploughed and leveled to give it a good tilt, and the land should be cultivated frequently so that it reduces the loss of moisture, and then the canal should be lined so that there is no seepage and percolation losses, and parallel canals should be constructed so that the losses of the if there in case if there are two canals running side by side, and the flood level will be lowered, and the losses thus will be reduced. In case there is too much of flooding, so that flood water can be diverted to the adjacent canal, and thus it can the excess runoff losses can be reduced, and it should have a idle length of the canal should be the idle length of the canal should be reduced. So idle length is the length uh, which is driven from the point of sight to the from the that means from the source to the point of application, so that length should be lowered, and the alignment of the canal either in sandy soil should be avoided, or fissured rock should be avoided, and the source of the supply should give a good quality of water, and there should be a rotation of the crops so that all the nutrients are properly utilized. And the farmers must be trained in proper usage of water. Then the land should be redistributed to the for farmers so that they get only as much as land which is capable of managing it. And there should be a research stations to study the soil and conservation of moisture. The canal administration staff should be efficient, responsible, and honest. Okay, that's all for today. Thank you.